Okay, so we have a ramp that we're calling a triangular prism, and we're not staining the bottom. So we have one big rectangular top side, one of those. We have two triangular sides, and then I'm calling this the front, but it would be the rectangular side that maybe goes up against whatever the ramp is going to. Okay, so we have three different unique shapes. So let's start with the first one. That big rectangle on the top is 25 feet by 5 feet. Okay, so length times width for a rectangle should get 125.4 square feet, roughly. Any questions on that one, on that piece? There's only one of them, so we don't need to double it or anything. Okay, and then the sides are triangles, and the height for the triangle is in inches. So in order to be consistent with the units for the length, we need to, or for the base, we need to convert to feet. So 25 inches is 2 1/12 feet. And then we just do 1/2 base times height. And I got 26 and a small decimal. It was 0.0 something. So I rounded to 26. That's not going to change how much stain you buy. And then double that because we have the front, like the side facing us, and then the side that we can't see. We have two of them. And then the front rectangle is 5, and again 2 1/12 feet. So that's the 25 inches. Multiply those, you get 10.4 feet squared. Then what do we do for the total area? Just add them up. So once you add all those pieces, you get about 190 square feet. And that thing up there said that one quart or can covers 100 square feet. So we need two have enough to cover 10 square feet left over, which won't be very much at all, right? But it's good to have a little extra. Sometimes wood is more absorbent than you expect with stain, and you have to stain it again or stain it darker than you want. Or not than you want, but to get it where you want. Anybody ever done stain before? Yeah, it's cool stuff. I remember my grandpa hired me to stain his garage. He had a detached garage, and one of the sides was so dry, I would put stain on it, and it would just suck in like a sponge. You couldn't even tell. And we were going to go through gallons and gallons and gallons, so we decided to paint instead. But how'd you do? Okay, so let's go back to what messed you up. Like, maybe take it in steps. Did you identify that it's surface area, first of all? Okay, that's critical. If I hand you a problem like this on a test, it's not going to say, please find the surface area. It's asking for quarts of stain. So you got to know that we're covering it. That's surface area. Raise your hand if you knew surface area, just so we can be clear on who got that. All right. And then the next thing to me was identifying the three faces, the three unique shapes that we need to find area of. So are we good on the top, triangle, and the front, the way I'm calling the front? Did that step go well? Okay, give me a thumb just on identifying the faces. Okay. And then how about finding areas would be next, finding areas of the faces. Two of them were just rectangles, and then the triangle is just 1/2 of a rectangle. Thumb on that. Thumb on the areas. Is it because of that 1/12? Is that why?
Well, I tried converting them all to inches and then switched them back at the end, and I got it black.
Okay, so I want you to think about this. How big is 1/12 of a foot? It's 1 inch, right? So what if we called that dimension 25 feet, and we called this dimension just 2 feet? Is that going to change how much stain you buy? I mean, really? For this project? If you were staining 50,000 of these ramps, maybe you're a retailer that sells them, yeah, then you got to make sure you include the 12th, right? But if you just have one ramp at your house that you want to stain, is 1 inch going to change it? No, not enough. Definitely it wouldn't change it as much as messing up the math, right? Like that's going to mess things up bad. So my point in saying that is, in reality, like meaning at your house 20 years from now, when you go to Home Depot to buy stain, you don't probably need the 1/12th. Okay? Yeah.
I mean, I can get it alone. Like, it's not that I actually struggle finding the basis of the area. It's just that I was not paying attention to the feet or inches. And so for like the 1/12, I made up just the decimal. I wasn't paying attention that it was feet. Maybe we can put it like feet. And then for the 25 inches, I didn't see that it was inches.
So you did 25 feet.
I did 5 times 25 points.
So you have like
I got like
15 cans or something.
yeah.
See, that's what I mean. Well, that's okay. If you actually were measuring this, you wouldn't have been like, oh, I just measured the inches and then forget, right? That's one of the gaps between classroom and reality, because in reality, you either designed this thing or you actually just measured it with the tape measure, so you would know which units you're dealing with. But I didn't really get what you said here, because the decimal for this would be 25.0833. That's okay to use that.
This is 0.83.
No, it's 0.08. Do 1/12th on your calculator. So that would make a difference, because that's 8 times bigger in the decimal place. Well, 10 times actually.
I think I did 100 divided by 12.
Okay. Anyway, this is good to know. Like, have you ever painted your bedroom or painted your house, something inside, right? People shouldn't, and I don't know if they do, because I've never been this. Never mind, I better not say that. I've never struggled with math, so I've never had this problem. But people shouldn't just go to Home Depot and buy paint and hope they got the right amount, right? Should people do that? If you hire someone to paint your house, is that what they do? Like a contractor? Are they going to just show up and be like, yeah, that looks like about 6 cans and go? Probably not, right? At least they shouldn't if they know how to run a business. So most likely you will paint something in your house someday, okay? And if I asked you to paint this room, what would you do? Like, actually, sometimes the district sends people in to paint classrooms when they get kind of beat up looking. So, what would you do?
I measure the walls,
What would you measure about the walls?
the height. Well, I guess we probably know the height already. So
Do we? I don't know the height. I can ballpark it. Like, this is just under 8 feet, so I'm guessing that height is probably roughly 10 feet.
but like the people who paint these all the time.
Where, I'm talking about you. You. Go paint my classroom. How much paint do you need?
The height times the
Height times width for every wall. Okay. What about over there?
same thing.
Except cut out the window.
Yeah.
Cut off the cabinets, right?
Yeah.
Don't assume the height's the same. What about up here?
All the boards.
Now, I don't know if they take those off to paint. I sort of doubt it. I'm pretty sure they won't take that off. Maybe. It's actually easier to take off than the whiteboards.
Really?
Yeah. Okay. But you'll do that someday, I promise, because nobody wants to pay somebody for a job you can do in 2 hours by yourself, right? Like, hey, let's change the color of the bathroom. It takes you 2 hours to paint, you know? Like, who's going to pay someone to do that? You shouldn't. You shouldn't. Okay? So that's a surface area calculation. How would you know how many cans of paint to buy?
Well,
They do, yeah. Like sometime the number that comes to my mind for the paint we bought is like 400 square feet per gallon. So, and then that can change. Like if you're covering darker paint with lighter paint, you might have to go over it like 3 times to make sure it doesn't show through, that kind of thing. My sister told me just this over a break, we saw them, her and her family, when they first moved into her house, to their house. She tried a couple different paint colors on the wall, like bought samples and rolled it on, and the painter didn't cover them up properly. He like didn't do the job right, so she can still see them showing through the paint they chose. Who knows why? Don't do it like that if you ever be a painter. Okay. These are good problems. Like I told you, this unit is by far the most applicable unit that we've done and will do in this whole year, actually, for you guys. So try to dig into it and see beyond just, oh, I got to do this for homework or this for math. Like, see beyond to, I'm kind of getting practice doing things that I will do someday. Guarantee you we'll paint something someday. And you guys are probably not the kind of people who should just guess. Do you agree? Not if you're in accelerated class. You're not the kind of people who pay other people to do your math for you. Maybe. That's my opinion anyway. Okay, let's check your homework. Some of you did the volume also, which you didn't need to do. Here are your numbers for the first one. Surface area for that. What is that shape called specifically? It's a cube, right? It's a rectangular prism, but a special one called a cube. So we have 6 faces that are all 7 by 7. So in this case, you can just do 7 by 7 times 6 faces. You get 294 square meters. A 7-meter cube is huge, right? That would be, well, it's not huge, but it's like, it'd be way bigger than this room because it would be about twice as high. So that's a pretty big thing. Number 2, by the way, some of you mentioned this worksheet's formatting was kind of annoying, which I 100% agree with you. So we're calculating surface area. That's what you're checking. If you don't have all the A's, B's, and P's and all that stuff filled out, I don't really care. Next one, rectangular prism, and just has several different faces. So this one was 124 square meters. Any questions on that one? Number 3, a triangular prism, kind of like our ramp, if you turned our ramp on the side. And so this one, 168 square meters. By the way, the B's there were helping you find the area of the triangle, the base is all. Okay, any questions on that one? How many of you got that one right? 168 square meters. Okay. You had a question? Yeah, let's do. Maybe I'll get rid of all this work just so we can talk through it without it. Cut. So surface area means that we need a height of the triangle, right? And a base of the triangle. So you can see I wrote a 10 in there, but that was not given. Whoa, that's huge. So how did we get the 10? The Pythagorean theorem. And if you notice, this is just multiples of a 3, 4. So that's a multiple of a 5, right? So it's a 3, 4, 5 right triangle. So 3, 4, 5, but it's all times 2. So it's 10. That's where the 10 came from. Okay, the 6 is the height. We know that because of that right angle right there. So the area of the triangle is just 1/2 times 6. Let's actually do it in order. 1/2 times 10 times 6, which is 30. Are you good so far? Okay. And there are 2 of those. So that's going to be 60. Okay. And then we have, let's try this. We have this face over here. What are the dimensions of that face? 6 by 5, good. That's 30, and there's only one of those, right? Okay, and then we have the maybe call it the back face. Something like that. What are the dimensions of it? 8 by 5, so that's 40. And then we have the front face, which is going to be kind of hard to show. Just kind of highlight it there. It's kind of muddy. What are the dimensions of it? Yeah, 10, 5 by 10. Okay, so we add those up. 50, 40, and 30 is 120. Plus 60 is 180. I'm getting, so why did I get whatever I said before, was it 168 that I said before? Okay, let's figure that mystery out. So I wonder, I need to erase this, unfortunately. Yeah. Oh, okay, I did it just now. I did 10 as the base. What should I have done? I'm not sure why I did that. Should have been 8. So that's all. 8, so this is 24 times 2 is 48. Okay, so 120 and 48 is 168. Does that help? Okay. So we didn't actually need the 10. Yeah, we did, because we needed AB, the front rectangle. Any others on here, on that front page to do? Okay. Next page, cylinder. I left it in terms of pi, so 112 pi. If you multiply that by roughly 3, you're going to have like 350 or so, roughly. Okay. Any questions on that one? By the way, back here on this, why did I write it like that? So surface area, that pH stands for perimeter times height. And then the 2B is just the area of the bases. So that's another option. Perimeter times height for these kind of prisms. But I don't like that as much, honestly. It's kind of a shortcut. All right, let's go to the back. This is a triangular prism on top of a rectangular prism. But because one is stacked on top of the other, we don't include some of the, like we don't include this gray part and that gray part. Okay? Say it again.
Yeah, you don't count them?
This gray part, like the bottom of the rectangular prism, we don't count. Why not?
Because it will be counted in the other one.
We won't ever count it.
Because it's a house.
Yeah, you could think of it that way. Maybe this is, if this is a house, this would be like maybe the stairs going up to the second floor, right? But it's not exterior, so it's not surface, if that makes sense. And then the bottom, it doesn't actually say that, but I'm assuming because it's grayed out that we won't count that bottom. I would say if you did count the bottom of the rectangular prism, it could be okay.
Ours is part.
Oh, is it? Oh, gosh, yours is totally different, isn't it? So did you, well, you still shouldn't count the bottom of the triangle, the triangular prism. Except for it's not a surface area. The bottom of the triangular prism is not a surface. Yeah. So definitely don't count that. Let's say don't count that part. And I don't know what I did, so we'll have to look. But anyway, for the top, so the triangle, there's two of those. I got, so it's a half times 4 times 6. This six down here, not the 6 on top. So that's our base. And then, so that's 12, and then 2 of them, since we have a front and a back. And then we have these two rectangles on the side. How long is this piece? Yeah. 6 by, well, we don't know. Do we? No, we don't. How long is this piece right here? How do you figure that out? Do you guys see why? Because the rectangle is 6, like the 6 that goes across the top of the triangular prism, like the top of the roof, so to speak, the apex is that 6. But the pink line here is the width, length, whichever one you want to call it, of that rectangle. So what is that length? And how do we get it? Huh?
If I get it there.
Yeah, so 4, and then this is an isosceles triangle. Looks like, since that is perpendicular. I'm thinking geometrically, is that safe to assume? I don't know if it is. I think probably we should have been told that. Okay, so 3, 4, and then what's that diagonal up there? If it's a 3, 4, what's the length of the hypotenuse? Okay, so 3, 4, 5. Okay, so the area of that is 30. This is right where I had to go to my duty yesterday, so I think I thought I was done with it and I wasn't. And there are 2 of those, so that's 60, so this really should be 94. Okay. Any questions on the triangular prism? Anybody get 94? Well, if you take off the bottom of it, did you get 94? Okay. Anyway, then the rectangle, let's see if I forgot something there. So we have the the front and the back. It's just 4 by 6, that's easy. And then 4 by 12, that's the right side and the left side. I'm calling this the right side, and then the left side would be on the back. So that's 4 by 12. Okay. And so those add up to 144, but I forgot one piece. Do you see which piece I didn't do? So I did front, back, right side, left side. Which piece did I not account for? And I remember now, this is when I got back from duty at lunch. I just called it good and moved on. Okay, so it's this kind of top, maybe like the top of the garage or something if this was a house, right? So that surface, what are the dimensions of it? 6 by 6, right? It's a square. Okay, so we need to add 36 to this, which makes that 180. Okay, so 274. All right, any questions on that one now? Okay. Did anybody get it? Braden, you seem like you were ticking along pretty good.
Wait, isn't so the top one, wouldn't that be 84?
Yeah. You're 64. Yeah, you're 8.
Oh, is it? It's 24 plus 60. So take off 10. What a mess. All right, how'd you do now?
I'm checking that bottom. I feel like I didn't know the wrong, so I'm trying to see if I can figure it out.
And I didn't count the very bottom. I saw this kind of like a house or a shed where you wouldn't count the bottom as part of the surface, right? There actually isn't a bottom in most cases. There's like different pieces of it, but it's not like all contiguous. All right, surface area of prisms and cylinders. Give me a fist of 5. Cool. Do you have a question?
No, I figured it.
You got it?
I realized I don't know what I did, but I realized it quite fast.
Okay, awesome. All right, well, let's do volume now. Volumes are easier than, for sure, easier than surface area. Okay, so I'm going to add prism just under these prism notes so they're all together. So this applies to any prism. And I think I'll do it this way. Base area times height. So big B to remind you that it's the area of the base times height. Guys, the way to think of this is if you stack a layer in the bottom of a figure, and then you just count the layers, okay? So the bottom layer would be the area of the base of that bottom, and then however many layers it holds is the height. Let's write that. I'm going to use the word bottom even though it's not always on the bottom of the figure. So just keep in mind that you could stand it up if it helps you visualize it. And then it's just times how many layers, which is the height. What kind of units do we use for volumes? I'm just titling the section now with all the information that's in there. What units do we use for volume? Kenzie, give us an example one. What units do we use for volume? Cubic feet. Yeah. Okay. So put that under here. Cubic units. It's always going to be cubic units. So cubic feet, cubic inches, etc. This is a cubic inch, in case you're curious. Like an actual cubic inch. So not very big, right? How big is a cubic foot? Can you kind of trace it out with your hands in the air? Here's a 1 foot. So a cubic foot is pretty big, right? It would be 1 that way, 1 that way, and 1 that way. I'm looking around. It would be bigger than that box on the wall, but that's kind of getting close. Okay, that's about a foot tall and a foot wide, a little less, but it doesn't stick out a foot. So bring this box out here, and that's a cubic foot. You see how it's pretty big? How many milk jugs could you pour into a cubic foot? Take a guess. How many milk jugs could you pour into a cubic foot? Huh? 4 to, huh? A milk jug, like the big one, like a gallon. I'm asking how many gallons? 5. Okay. It's actually 7.48 gallons per cubic foot. So about 7.5 milk jugs, big milk jugs, could pour into that if we added that extra couple inches. That's a lot, right? Surprisingly a lot. The reason I'm telling you that is because in America we measure a lot of volumes in cubic feet. But most people relate to gallons better. So like if we looked right now at the river, the flow rate of the river, it would be measured in cubic feet per CFS, cubic feet per second. And so most people are like, I don't really know what that is. Multiply it by 7.5. That's how many gallons were flowing down the river. Which right now it's kind of low, so. Okay, base times height, area of the base times the height, always. It's actually true for a cylinder too, except what is the base of our cylinder always going to be? Okay, I want you to draw the little cylinder as a subscript. Or I suppose you could use CI or CYL if you'd like, but you need to subscript these things so that you know which one you're using. Okay, I just told you it has the same exact relationship as a prism, so area of the base times the height. But what is the area of the base in a cylinder? Always going to be. Pi r squared, okay? So for this, it's pi r squared h. Area of the circular base, that tells us how many square units are in the base, and then times how many layers that we have. Okay, so area of the circle times the height. Make this note. This is still just area of the base times the height. That way, if you forget, you can just be like, oh yeah, it's area of the base. It's still sort of an infinite-sided prism. Okay. I'm going to clump these together. This is all our cylinder stuff. And this is all our... Actually, let's just do prism. All our prism stuff. Okay. Any questions on the formulas before we go use them? Okay. Volumes are kind of, I think, more fun. I don't know that they're always more useful. Okay, a couple of reminders. We talked about Cavalieri's principle, which said as long as the cross-sectional area is the same and the height is the same, then the volume is the same. Okay, so here's a picture of that. Again, just to remind you, all three of those objects have the same volume as long as their height is the same and the area of this piece that we're cutting is the same. As long as that's true, the whole thing is the same volume. Okay. Oh. Seriously, this thing is annoying. All right, tell me what you think about this. I don't know why you would have a crooked canister in your pantry, but maybe just for decoration. What do you think? Let's call them green and orange canisters. I don't know. This person likes color in their pantry, I guess. And it looks like they're probably packing lentils in there. You like lentils? Lentils are good. I can't eat them, but they're good.
Oh, I have a question. How do you know the height of the green one? Or
Yep. What is the height of the green one? Also 25, right? Okay, I don't know if that helps you answer. Zeke, can you wake up? Maybe stand up. Okay, first question says, which canister holds more? Do we think that one of them does? Okay, isn't this Cavalieri, right? Do they have the same cross-sectional area? Here's what I mean. If we could cut it right there, each of these jars, and then turn it and look at that circle that we just cut, would they have different areas on that circle? So can I say same cross-sectional area? I'll just say same cross-section. Are they both the same size circle? Are they the same height?
Yes.
Okay. I don't want to answer this second question right now. We'll do that in a little while. Okay, so how do we find the volume of either one of them? Pi r squared times height, right? Easy enough. All right, here's a cool one. Anybody ever play in a sandbox growing up? Okay. Sad. That's too bad. If you got to, that's good. Sandboxes are fun. Okay, so Marta is repurposing a sandbox. Maybe her kids grew up and now she wants to use it for a raised bed garden, which is a really effective way to grow things. And so she's buying soil. Estimate the number of bags she should buy. Okay. How can we? I'm going to let you do this one, but I want you to answer, how do we model the volume of the soil bag? Because it's not really the shape that we would describe as something we know. It's like a packet, but it doesn't look like a shape. But we can ballpark. Remember, this is your backyard. If you're off by a few, in this case, it'll be, well, I don't want to actually tell you that because it'll give it away. But if you're off a little and you happen to buy an extra bag or maybe you have a half a bag left, that's not a big deal. So what are we going to approximate the volume of the soil bag as? A rectangular prism. Make sure you say it, the whole thing. Okay? So I want you to think of this. Don't worry about trying to get the exact shape of it. Just assume that it's a rectangular prism. And let's figure out how many bags to buy. Guys, think about the reality of this. Again, like I was saying with the warm-up, don't just treat it as a math problem to get done with. You might do this. I've done it at my house. Like, gone and bought soil to fill a raised bed garden. Okay? I had to calculate how much to buy. It was like a dump load into my truck, but it was still, I had to tell him how much to put in there. Okay? This is something you probably will do. Maybe you're just filling it with sand for your little kid instead. Okay? Think of it either way. Give it a shot. All right, well, first thing to note is that we have a mismatch of units. So because the bags are, we're wanting a bag count. It doesn't actually matter which one you pick, but I think probably doing inches is better because the bags are in inches. So of course this is 48 and this is 48. So the volume of the garden, and again, subscript your work so that you're keeping track of stuff in an organized way. This is just length times width times height. So the area of the base is length times width, and then the height, okay, is 10 inches. So 48 squared times 10. What's that number, please? Thanks for the help there. What was it?
23,040.
Thank you. And that's cubic inches. So it's 23,000 of those little purple cubic inches. This thing. Okay? Which is kind of hard to visualize if that's a lot or not. Okay, volume of the bags. Well, it's going to be, it depends now which one you call the base. I'm going to call it the 10 by the 18. So 10 by 18, that's the base, times the height of 5. And what is that? 900, also cubic inches. So can you visualize 900 of these stuffed into a bag? It's not a very big bag, actually. Okay. Anyway, how do we find the number of bags? Total volume divided by bag volume, and we're getting 25.6. And so we need 26 bags to fill it up. Okay? So you will make your husband do that, you said?
She has a point.
What if you're smarter than him?
I'll do the math for it, but then I'll just tell them what to go buy and what to do.
Okay. A few years ago, we had a math teacher who, she moved, but who was doing some version of this project at her house. And this is the disconnect. Like, this is why I'm trying to push you to use your math in real life situations, because she didn't know what to do or didn't do it. And she ended up having to drive from Fruita to Home Depot, she said, 3 times to go buy more bags of stuff. Wouldn't that be a pain? Right? Like, use your math to calculate, save you the trips, and it's just better.
What was she doing?
I can't remember. It was some version of this. Like she had to, I can't remember if it was sand or soil, but and what she was building. She didn't have kids, so it wasn't a sandbox. Maybe like a garden planter or flower bed or something. Well, don't give up. Okay. Let's do one of these kind. Anybody ever made frozen juice where you have to stir water into it? Like the frozen concentrate? Oh my goodness. You have? She does it all the time.
Is it in a can or something?
Yeah.
You freeze it?
Well, this looks like maybe it's just liquid, but the kind that are the most tasty, it comes in a can like the size of a Coke can, like that size roughly. But it's a paper, like a cardboard waxed paper can, and you peel it off and you mix it, like put it in your pitcher, and it's just a frozen chunk of concentrate, and then you mix water with it. But I think it, for me at least, it tastes more fresh and real, not like just sugar water. Do you agree?
I don't really like orange juice.
Well, they have it with other kinds too. Anyway, you should try it. Those little cans are usually only like $1.50 or something. I don't know. You don't know? What kind do you like to make?
Okay. Well, just like
Okay. All right, how many cans of juice will she need to mix in to fill this pitcher up? What are we going to do on this one? It says the pitcher is 11 by 11 inches tall and a radius of 4. And each juice, each can, this is liquid juice, so it's the gross can, is 6 inches tall with a radius of 2. Okay, what are you going to do? And just figure out the volume, divide, right? Same thing. What's the volume of a cylinder? Huh? Yeah, go ahead.
If like both of them are like pretty much half of what it is,
Ah, so she's saying the 6 is roughly half of the 11 and the 2 is half of the 4. So, I'm a little disappointed that you have to ask me that. But it's also good that you are. We're dealing with volume, and the 2, 6, 11, 4, those are lengths, right? Is it a direct one-to-one relationship? So think back to our area ratios. What did we have to do to bump from linear 1D to area 2D? Okay, this is now linear 1D to volume 3D. So what are we going to have to do? Cube it, right? So do you think it's just double? It's probably more like 8 times as much, right? Because 2 cubed would be 8 times bigger.
Yeah.
Okay. That's a good thing to keep in mind. I'll tell you why. My sister told me a story just over break again. That somebody, I can't remember if it was her or somebody she knew, was offered thinking pizza, like a 9-inch pizza versus, well, hey, we can't make a 9-inch pizza for some reason. I can't remember why. There was an issue with it. So would you take 2 5-inch pizzas? Oh, you get an extra inch. Right? Is that true? Would you be like, oh, I get an extra inch for the same price? Or would you be like, dude, go do some math? Which one is it?
By your answers, do go get some by your facial expressions.
Prove it. That's going to be your homework. Okay. All right. Do you guys ever have Tetras, these little neon blue and red fishies?
No. Oh,
What the heck do you guys do? No sandbox, no fish, no orange juice, no frozen orange juice. Okay. You're gonna do this slide for me, please. We still have 20 minutes. It might take you that long. Okay, so first we need the volume of the tank. So this is a cylinder, or at least we're modeling it as that. Okay, and so we have a radius of 8 and a height of 32. So 64 times 32 times pi is 64, let's call it 6434. Everybody good with that? And what are the units of that? Okay. So I ballparked a little high, sorry. All right, and then how do we, that is inches cubed, that's purple cubic inches. That doesn't really help us because most of the time the tank would probably be in gallons, right, on the box. So how do we convert from cubic inches to gallons? Divide by, okay. What'd you get there? Okay, I can do it. 27.9. Okay, here's my question. That is now in gallons. This is what I was asking Lyra. Do we want to call that 27.9? Do we want to round it to 28? Does it matter?
I don't think so. It's
Well,
fish.
we could do this for the fish. What do we do to find out how many fish? Okay, so divide the gallons by 2. So, what are you guys talking about right here? 13.9. Do your fish want you to round that to 14, or do they want you to round it to 13?
They don't get a say. I don't even think point one would make a difference to them.
Okay. I'm just curious. I think because it's 0.9, we can probably make an argument both ways, you know, like I would round to 13 because it said they need 2 gallons. If we put 14 fish in there, they're not getting 2 gallons each.
You're right, you're getting 1.992.
Yeah. They're missing a few tablespoons.
Yeah.
So. Okay.
Here we go again.
So what's happening?
Should we leave the fish alone for now? Okay. Mulch. You guys know what mulch is?
No.
Did you ever swim in a kiddie pool?
Yes, I did that. I did.
Okay.
I love swimming.
I want to do the tree one because that's one of my favorite things in life. Is trees. Anybody ever been to the sequoias? If you ever get a chance to, you should. Huh? Okay. I want you to visualize this. Okay. These are not I don't know if they're the biggest ones, but. So, first of all, the heights are enormous. This is like 30-story building. So like 3 times as tall as St. Mary's. 2.5 times as tall as St. Mary's, are these trees. That's pretty cool, right? And then their circumference, that's a little hard to visualize. Everybody convert these to a diameter, please. And I'll write them down. So how about this side of the room do tree A, middle do B, and this side do C. Okay? So I want the diameter, because circumference is hard to visualize, like I said. Okay, let's go. You have B.
B is 34.7.
34.7 feet. Thank you. Okay, A.
16.
That's too small. It should be
Diameter.
the diameter. Yeah.
32.
0.1. Cool. Thank you. Okay. So I want you to stop and think about this. Now we have it in a more relatable form. So these trees are 2 to 2.5 times as tall as St. Mary's Hospital, because it's about 120 feet. And their trunk at when it says measured at 4.5 feet, that means 4.5 feet above the ground. It's like chest level. All three of these are wider than my room is this way by a couple feet. These trees, like they're amazingly beautiful, huge trees. They're cool. Okay? Yeah, I've seen them. They're amazing. They're located in California, sort of southeast of San Francisco. And there's actually a national park, but anyway, they're enormous, right? They're cool. If you ever get a chance to go there, it's worth it. So, here's a question. This is just concept. Are you guys part of this, or you might as well just go outside? You sure? Okay. I mean, you can have your conversation. Should the forester use surface area or volume to describe the size? What do you think? If we're talking size of a tree. Why volume? Not necessarily. It has a surface area. It's like the outside of its bark, right? Oh, okay. What? Well, it's really a question of like, if you said, hey, that's a big truck or a big pizza or a big ice cream cone or a big mountain, like, are we talking about the surface size or the mass of it, right? So which one kind of speaks to mass more? The volume, yeah. Because if you remember from science, density is mass, like kilograms per volume. Okay, so when we're thinking of how big, how massive, the volume plays a role. Okay. How would you model a tree to find its volume? When I say model, I mean it's not actually this shape, it's just we can approximate it that way. Cylinder, right? Okay. So we're not going to actually do that because it's too basic. Just plug in the numbers, but... All right. I think I'll save this kiddie pool for tomorrow. I have a picture of me standing in front of the biggest tree on Earth, which is called General Sherman. And I'll try to remember to bring it tomorrow. It was so cool. Yeah. It's in Sequoia National Park in California. We'll just do a couple of these. It's not super far from each other, but they're different trees.
Okay.
Redwoods are taller, but not as big. Like not as large. But they're still. Yeah, you could. Alright, let me tell you which ones to circle. By the way, tomorrow, you guys know what we're doing tomorrow? NWEA, so please bring your Chromebook charged up. I have some reminders going out tonight and tomorrow morning. And then, so we won't check this tomorrow, we'll check it Friday. So if you don't want to do it till then, that's fine.
I'll be just doing 13, right?
Yeah.
Just 13?
Yeah,
That's
you agree with him.
Sure, let's do 13 and
14.
14. Oh, you're right.
no, I like these ones on the right side. So
Oh, I literally just so just
has anybody ever dug a hole and hit a rock?
I have.
Yes?
I was
It's so annoying. So let's do number 18 just so you
That's it, right?
can feel the annoying.
Just 18 and that's it.
No.
Oh, I like 19.
Number 20, we all can. Has anybody ever wrapped coins before?
No, I've unwrapped the coin.
Where you have to count the right amount for the coin wrapper?
I've never done that, but I've unwrapped them.
Okay. Do number 20 so you get some coin wrapping experience.
Oh, okay. And that's it, right?
You just sit there and you visit and you like count pennies, 50 pennies at a time. Pennies are the worst. It's 50 cents for each penny wrapper. It's $5 for each nickel. $10 for dimes. Or maybe quarters, I can't remember. Okay, and then quarters is,
11 maybe.
it's something else, but.
Yellow.
What okay, number 23 is the kiddie pool problem. Let's do that. And then,
We're doing that
Yeah.
for tomorrow.
Yeah.
okay, don't do that then. Do number 22, the mulch problem. I guarantee you'll buy mulch in your life. Okay, so that was 13, 18, 20, and 22. 13, 18, 20, and 22. You'll buy mulch.
No.
You will. Are you going to live in New York City?
Yeah.
Yeah.
Sounds like a perfect idea.
Didn't they like plant a bunch of trees?